Yo, Chad, I'm back again. I really wanna be done studying today, but I can't actually do that. But let's try to finish as much as possible, Chad. Okay? That's my goal for today.
Find out what is n and what is r. N is basically the exponent that you see here. So n is equal to 6. Now what
I found out why I was wrong, Chad. About to give the answer. Yo, Jupiter, is that you? Has to be Jupiter. Welcome. 6 times 5 times 4 factorial divided by 4 factorial 1 times 2 times 3. Boom, boom. Bro. Okay. Times 5 times 4 times 3. Yo, if you're watching the stream, say something in the chat. I would really appreciate that, bro. If you know what I'm saying. I kind of want to stream on Twitch today. Recommend categories. Boom, boom. So 6 times 5 times 4. 3 times 1, 1, 2, 1, 2. 5 times 2 is 10, 10 times 2 is 20. So the 27 times 64 is minus 1,728 times 20 minus 34,560 x cubed y cubed. I did it! Did it, chat?
What about R? Well, R is 3. Now what about R? Well, if you're looking for the fourth term, R is going to be 1 less than the fourth term, so R is 3. So with that, we could find the term and its coefficient. So it's going to be NCR, which is 6C3 times A. A is basically 3x, which is raised to the n minus r, which is 6 minus 3, times b, which is negative 4y, and that's raised to the r power, which is 3. And 6c3, that's 6 factorial, divided by n minus r, which is 6 minus 3 factorial, or 3 factorial, times r factorial, which is also 3 factorial. And 6 minus 3 is 3. So now let's figure out what this is equal to.
Once I figure it
6
out,
factorial is going to be equal to 6 times 5
I realize
times 4
it's not that
times 3
complicated.
factorial.
Once I figure
And 3
that
factorial
out, I
is 3
realize
times
it's
2
not that
times 1 times the other 3.
It's not that complicated as that.
6 times, well, 3 times 2 is 6, so that cancels, leaving behind 5 times 4, which is 20.
Figured.
So let's make some space.
Figured.
So we have 20 times 3x to the third power is 27x cubed. Negative 4 to the third power is negative 64 times y cubed. Now, if we multiply 20 times 27 times negative 64, this is going to give us negative 34,560. And then you can see it's x cubed, y cubed. So this is the fourth term, and the coefficient of the fourth term is negative 34,560. Now let's find the value of the fifth term using the same expression. Now, if you rewind the video,
Let me do it by myself first. NCR equals a raised to the 9 minus r power times b raised to the rth power.
expression. Now let's find the value of the fifth term.
Fifth term. So we're looking for the fifth term, which means R is 4. So 4 minus R. Okay, hold up. 6 CR is 4. So 3x raised to the, what is 6 minus 4 is 2, second power. So B is gonna be 4. B is gonna be 4. B is gonna be minus, let me rewrite this again. Let me rewrite this chat. 3x raised to the second power times minus 4y raised to the fourth power. I think I got it right, if you know what I'm saying. That
Olha, hoje eu vou te levar pra ver tudo que eu como.
x squared 4 times 4 times 4 times 4. What the fuck? What is 4 raised to the 4th power? 256, okay. Six C4 equals n factorial divided by r factorial times n minus r factorial. N is 6 factorial, 4 factorial, 6 minus 4 factorial. Just 2 factorial. 6 times 5 times 4 factorial divided by 4 factorial times 2 factorial. Boom, boom. 6 times 5 divided by 1 times 2 times 1. 3. 15. And 6 times 9. 34,560. That's the same answer, chat. X squared y raised to the fourth power. How is that possible? So 9 times 246 times 15. It's the same fucking answer. It's the same fucking answer. Same fucking answer. 34,560. X squared y raised to the fourth power.
E4, that's n. 2 factorial is simply just 2, so we can cancel 4 factorial. 6 times 5 is 30, divided by 2 is 15. 3 is 250. That's 34,560. And we have an x squared and a y to the fourth. So as you can see, it gives us the same answer.
It gives us the same answer. That's what I told you, chat.
So find any term and its coefficient by using this expression. So just remember, n is basically the exponent
Do I have binomial distribution? That's, or if I have that too, that would be fucking. Binomial distribution. Do I have that? Do I have that? There's no fucking summary here. Okay. Combination is the selection of items from a larger set where the order of selections does not matter. Without repetition, items can be chosen only once. With repetition, items can be chosen multiple times. Binomial theorem describes how to expand expressions of the form of the from x plus y. Pascal's identity is a way to calculate binomial coefficients recursively. Pascal's triangle identity, Pascal's identity. I didn't learn that though. Pascal's identity. Pascal. Okay, let me look it up first. What is what is Pas Pascal's Pascal's identity? Identity. I didn't learn this shit. Pascal's identity. 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 Fuck. Script man. Sigma notation. Whoa, my man does not have a video for that. Art of problem solving. Pascal's identity.
I'm part of a group of 12 very indecisive people. We have to form a bunch of committees to get some work done. We're constantly arguing over who's going to be on what committee, who's going to do what. So finally, we formed a committee to decide how to form the committees. Now, we decided we have 3 of our 12 people will be on this committee on committees. And we choose them at random. So first we'll note there are 12 choose 3 ways to make this committee on committees. And again, we'll be choosing them at random, but I don't believe there's such a thing as a random committee. See, there are 2 types of committees. First, there are the bad committees. And the committee is bad if I have to be on. So the bad committees are the ones with me. Now, fortunately, there are good committees. And the good committee is one that I don't have to be on. So now let's see how many ways we can make a bad committee on committees and a good committee on committees. So if the bad committee of 3 people, that means I'm one of the 3 people. But we still need 2 more. And there are 11 other people to choose from. So there are 11 choose 2. Bad committees. Don't like any of those. That's just bad. How about the good committees? Well, if I'm not on the committee, always still 11 people left to choose from. We have to get all 3.
Committees.
People. So there are 11 choose 3 ways to get all 3 people from the other 11 to form a good committee. Now, every single committee is either bad or it's good. It's one or the other, and it can't be both. So that means when we add up all the bad and the good committees, we get the total number of committees. Now, there's nothing special about 12 and 3 here. maybe we can use this same idea and come up with a new combinatorial identity. Let's take a look at that. What I'm going to do is erase all this, just keep the bad and the good committees, and say that you take me and then n other people. So there are n plus 1 total people. That includes me. And we're going to form an R plus 1 person committee. Now, clearly there are n plus 1 choose R plus 1 ways to form the committee. Now, what about the bad committees? These are the committees that I unfortunately have to be on. Now, if I'm on the committee, we need R plus 1 people total, so we need to choose R more out of the n remaining people. So there are n choose R ways to form a bad committee. And then the good committees, well,
It's my
here we still
fault.
have n other people to choose from, but now we have to get all R plus 1 to fill out the committee. And once again, every single one of these committees, it's either bad or it's good. Can't be both, can't be neither. So when we add together the bad committees and the good committees, we get all of them. So now, we have a new combinatorial identity. This is always true for any values of n and r for which these combinations are defined. And we have a nice counting explanation for it. But let's go ahead. When we saw the last counting out the combinatorial identity, we also had an algebraic explanation for it. Let's go ahead and see if the algebra will work here as well. And we'll start with the definition for combinations. We'll write it in terms of factorials. Then we'll see if when we add these two, we get that one. So I'm going to go ahead and erase this. We're going to try to prove this again using algebra. First, we'll write this in terms of factorials. N choose r, which is n factorial divided by r factorial, and n minus r factorial. This one's a little trickier, but not much. Still n factorial in the numerator. And on the bottom, we have r plus 1 factorial, and then n minus this total r plus 1, which will make us n minus r minus 1 factorial. Now we have to add these two pretty ugly fractions. So we'll start by getting a common denominator. First, we'll look at the r terms, and we'll see that this one, r plus 1 factorial, is just r plus 1 times r factorial.
Patterns.
So if we multiply the top and bottom of this by r plus 1, the r plus 1 times the r factorial will give us r plus 1 factorial.
If 13 people are seated in a row of 12 chairs, how many people must share a seat? What the fuck? physics. It's fucked up. I'm tired of this shit. I'm really tired of this. I am really tired of this. With the simplest, could you answer these questions with the simplest explanation? This I'll stop streaming for today, chat. No one is watching me actually. Nobody wants to watch me, bro. Yo, yo, yo. Yo, yo, yo. I think I need 2 mics. Also gotta hit the gym tomorrow. Should I end the stream? Oh, yeah. So bad. Alright, bro. Fucking hate this